Wow, Sammy Yuri built Minecraft in Minecraft with just redstone. Obviously you've heard of this, but that doesn't explain how a Minecraft redstone computer works. Well, today I'm here to tell you. Just to note, I will not build any redstone in this video. It's just a diagram with explanation to how computers and the components work. It's essential to start building, which will happen in the next episode. You'll also learn how real-life computers work because they work in pretty much the exact same way. I don't know where to start, but we might as well start by talking about the most important part. The ALU. This is a piece of hardware that a computer can't run without. Its sole job is to perform simple calculations, like addition and subtraction. That's it. Sometimes it can do multiplication, but forget division. It can also do bitwise logic, takes 2 input and has 1 output. Everything will be explained in more detail and the computational redstone series a bit more thoroughly. Next we have registers. Pretty self-explanatory, but it can store a few words of data, perfect for the ALU to easily read from and write to. Has an input, an output, and a decoder to decide which register it's pointing to. The place where the data stored is called an address. Think about this. The address is the house where the data lives at. Also, I'm breezing through these. You can find a lot more information on channels like Mapbowings and The Darkness 344. This little loop of ALU and registers is called a core, or can be turned into a thread. A core can focus on one major task, while a thread hops between tasks to perform even more tasks. With the CPU done, let's talk about RAM. Random access memory is similar to the registers, but its main goal is to store a lot more than a few words. In modern computers, they can store millions of them. They perform another task as well, because in some modern computers, the instructions are put onto the memory to be accessed way faster and perform more tasks. It has an input and an output, as well as a decoder, just like the registers. Different addresses have different functions, like instruction memory to store instructions, and the video memory to store textures and graphics. Just not in Minecraft. Unless you're Sammy Yuri. And if you're watching this, then you know little to nothing about the topic, so you're definitely not Sammy Yuri. Now, the previously mentioned RAM doesn't have enough space for all the instructions at a time. So that's where the storage comes in. The storage is similar to RAM, as it can execute instructions and send data out. Sometimes in modern computers, instructions are sent to the RAM to be executed. Now, the most important part of the computer, the counter and the clock. The clock ticks every few seconds, or nanoseconds. The counter does what you think, counting up to send to the instruction memory. The counter often sends its value to a register, then sent to the address memory or storage unit. Memory can also be read at multiple times per clock cycle. This is done so that the memory and storage can run multiple instructions to each core or thread. And then there's the ports. Data from the RAM can be sent out to a port where it can be stored and then sent out to a device connected to them. You can also take inputs, store them, and then send them to the RAM, so you can add external devices or even GPUs. Think of them as USB cables or M.2 slots in normal motherboards on real-life PCs. All these components work together with control lines spanning every corner of the computer to make it run programs and act as a fully functioning computer. Currently, I have a computer working in progress that I'm building. It's not done yet, but eventually. Hopefully this video helped you build a foundation for computational redstone in Minecraft. See you in the next video where we talk about the binary number system. Subscribe for more, and duck out.